In this video, we'll set up the Webpack-based toolchain that will help us compile our React code. Let's begin. In the previous video, we set up our project and downloaded all dependencies. We also built a server using Node.js and the Express framework, which will serve our React app bundle as well as the server-side rendered content. Let's now build the toolchain using Webpack that will compile and bundle our code. Webpack is a highly configurable module bundler that takes modular code and compiles it into bundles. In doing so, Webpack can be configured to process all kinds of files and assets such as style sheets, images, JavaScript, and even React code. You would recall we installed a ton of development dependencies including Webpack and Babel. Let's now write configuration files which Webpack needs to process our code. Now, Webpack has to process two kinds of code. On one hand, we have the React client-side application, which has to be compiled to a bundle. On the other hand, we have the Node.js server, which is importing the React app to be rendered on the server side. Hence, Webpack has to compile the React app on the server end again. So we'll begin by writing a configuration file, which will be common for both the server and the client-side environments. I'll thus create a file named webpack.base.js. We'll export an object which defines a module, which is a definition of a discrete unit that Webpack should compile. Here, we need to define rules or tests for files of a specific type. We'll define the file type using a regular expression test on the file. So all files with the extension .js should be loaded using the Babel loader. In doing so, we should exclude the node_modules folder since it contains all sorts of dependencies which need not be bundled in. Now, Babel loader needs to be configured as well. So we'll pass an options object where we'll set presets to the preset React and the env preset respectively. In simple words, we are asking Webpack to find files where the extension is .js and compile them using the preset React and env Babel presets. What this configuration will do is compile our JavaScript code, which includes React and JSX as well. Since this is required both on the server and the client, we have written it as a base configuration which we'll merge with a client-side and a server-side edition. This was about how Webpack should compile code, but we still need to configure several other things for the client and server respectively, so we'll first create the webpack.client.js file. Here, I'll create a client config object where we'll set mode to production, which will enable production time build optimizations. Webpack then needs to know an entry point, a file from where it starts to crawl and compile code. Since we are building the client-side app, this would be the index.js file in our app folder inside src. We'll then set the output file name to bundle.js, and for the path, we'll use resolve to create a path to a folder named JS within build. This is where the compiled client-side React app would be stored. I'll then write a module which tests for CSS files and simply ignores them from processing. This is because we'll compile style sheets when we compile the server-side code. The ignore loader simply ignores files that qualify the regular expression test. Now, this configuration needs to compile React code. So instead of writing a module definition again, we'll simply merge this client configuration with the configuration we wrote earlier in webpack.base. This is where the Webpack merge package comes into the picture. So let's import it first. And we'll import the base configuration as well. Then we'll use merge to combine both the client and the base configurations, and this is what we'll export out. Our client-side configuration is now ready. So let's write another configuration for the server. This will go in the webpack.server.js file. Now, Webpack can compile JavaScript for different kinds of environments such as the web, Node.js, and the Electron.js based desktop environment. Here, we'll set the compilation target as Node so that the generated code is compiled specifically for Node.js based environments. We'll again set mode to production for build time optimizations. Now, when compiling the app from the server end, we'll set the entry point as our server.js file so that Webpack can begin by this script and compile down the React app. We'll also set a property called externals, and we'll use the Webpack node externals package here, which will ensure that our node_modules folder and dependencies are not part of the compilation process. We'll then set the output file name for the server-side bundle as index.js and the path to the build folder. Now remember, we chose to ignore CSS files in the client-side Webpack configuration. Well, let's process them here, especially because I am importing my style sheet in the app component in this project instead of the index.js file. And the app component is being imported into the server.js file, so Webpack, in the process of compiling down code, will come across the style sheet and needs to know how to process the same. We'll first set a plugin called mini CSS extract plugin, which we'll import here. We are setting this plugin to simply extract the styles that it comes across as it traverses the app component to a brand new file on disk named style.css and store it in the CSS folder inside the build folder. The path resolution here is relative to the path set in the output property above. Now we have set Webpack to extract styles to a new file, but we still haven't configured Webpack to find and process files with the extension CSS. So we'll set up a rule in the modules section where we'll test for CSS files using regular expressions, and we'll use the loader from the mini CSS extract plugin as well as the CSS loader. Collectively, they will process CSS and write out a file named style.css in the CSS folder under build. Last step calls for using Webpack merge to merge this configuration using the webpack.base configuration, which skills up Webpack to process React and JSX code. Now to run these configurations, we'll go into our package.json file and we'll create a new npm script named build, which basically uses the webpack command with the config flag to execute the webpack.server.js configuration as well as the client configuration. But before we attempt to actually build our code, we'll go into the index.js file in the src/app folder, where our React app sits. On line number 5, we have the standard React DOM.render function, which renders our app component in an HTML layout where we have a div with the ID set to root. When producing server-rendered React apps, the render function needs to be replaced by the hydrate function like so. This function latches the React app to the root div seamlessly to enable interactive features in an otherwise static server-rendered HTML markup. With this done, our toolchain is ready. So let's execute npm run build on the terminal, which takes a few seconds and produces a new build folder with an index.js file, which you can see here after the application of optimizations. The JS folder contains the client-side React app, and we also have our extracted style sheet here. I can now run my app using Node.js like so, and the message on the terminal tells us that our server is up on port 3000. So let's open it in the browser. You can see our app in the browser, and it is interactive and functioning. If you view the source HTML for this document, you can see the HTML layout for the app, but we don't have our list items, which we can see in the client-side rendered version in the browser at the moment. This is because when rendering on the server, we did not bootstrap our app component with data fetched from the API. Hence, the app renders as an empty list until the client-side React app comes in and brings data and interactivity along with it. So let's go back and make a few edits. Our app component offers a prop named init, which directly sets the initial value of the to-do state property. We can use this to load initial data in our app because while rendering on the server, the use effect hook will not be executed and we won't get our data as we usually do on the client. Now remember, we had imported Axios in the server.js file but never got to use it. Well, now we will. So in your route handler, use axios.get to perform a GET request on the API endpoint. And once you have the data array, use that in the init prop to bootstrap your app before it renders. And if there is an error, we'll simply throw back an error message. Of course, you have tons of ways to handle this elegantly. I'll run the npm run build again to recompile our app, and let's run it using Node. And if you now see the HTML source here, you can see our server rendered HTML does contain all list item instances as well, just as we wanted it. The setup you built over these two videos is a bare bones setup that can be used to render server-side React apps. Since Webpack is highly configurable, you can sweeten the pot by adding abilities to produce chunks when dynamic import statements are used, and also loaders for processing images if you've used them in the project. Overall, the configuration here would depend on the exact case at hand. Having said this, probably the best option for most scenarios is to use a framework like Next.js, which simplifies the task of building server-side rendered React applications. You can read more about Next.js on their official website.